Hello everyone. Today I'm going to be demoing an electromotor. Though there are a couple of laws at play here, like Ampere's law, Lenz's law, and even Faraday's law from Michael Faraday, what I want you to take from this demo are the fundamental principles of what happens when you run electricity through a wire. So let's begin. Thanks to Hans Ørsted, we know that running electricity through a wire generates a magnetic field. This magnetic field kind of rotates around the wire. And knowing this, we can change the geometry of the wire into a loop, otherwise known as a solenoid or a coil. What this does is stack the magnetic field in a sort of additive fashion, which then resembles a permanent magnet. And you've probably seen these magnets more commonly as refrigerator magnets, where they have a north and south pole. Now for magnets, we understand that opposites attract. So putting two north poles with each other will cause a repulsive force, while putting opposites near each other like a north and a south pole will cause a attractive force, causing the magnets to stick. Here we have a permanent magnet, which we will be trying to interact with our solenoid, which is going to be creating an induced magnet. Thanks to Faraday's law, we can understand what an electromotive force is. In simple terms, this is what happens when two magnets meet. They will either attract or repel each other, which then we can predict movements, which you will see in this demo. So here are the materials we're going to be working with, and the ones you should have. First off, we have the Play-Doh. Next, we have a 1.5 volt battery. We then have a couple rubber bands, our copper arms. These will pass the current through our solenoid, and here is our solenoid. We're not going to be needing this piece of wire. To begin this demo, we'll need to start with our Play-Doh. We're going to be making a sort of platform for our battery. This will prevent the battery from rolling off the table. You can make it into whatever shape you like, but I like making an oval shape. This will make a good size for the battery. Next, we're going to make two spheres. These are going to go on the sides of the battery and prevent the arms from moving. These are the copper arms. They are meant to complete the circuit by passing the electrons to the solenoid, and they are also meant to hold the solenoid while it spins. We'll next use some rubber bands to keep the arms fixed on the battery and prevent them from moving. Be careful. These arms will get warm as the electrons experience a resistance running through the wire, so they may get pretty hot. Now here we have our permanent magnet. You're going to be placing it on the battery. Now which side you put it on does not really matter, and you'll see why in a second. You'll next place the solenoid on the arms and see how the solenoid moves freely. Now if all works well, you should immediately see an interaction between the solenoid and the permanent magnet. You now have two magnets interacting with each other. Give it a little push, and you should see the solenoid start to spin. Now what's happening here is that you have now created a magnet from your solenoid. This induced magnet is trying to interact with the permanent magnet below, regardless of which pole is facing up. As the solenoid is spinning, one side is trying to attract with the permanent magnet, while the other side inherently is trying to repel it. This will further the spinning motion of your solenoid, and it'll keep spinning until you remove it. Very awesome. Now I know some questions may come up from viewing this demo. For example, some of you may ask, will this solenoid keep spinning forever? Well, not exactly. Perpetual machines don't really exist. And to answer that question, the solenoid will keep spinning as long as there are electrons running through the wire, which is inducing that magnetic field. The solenoid will stop spinning once there are no more electrons running through it. And when will this happen? This will happen when the battery no longer has enough potential to support that current. Another question that you may have is, do we actually know what's going on here? As in, can we actually visualize the magnetic fields that are being produced by these two magnets? And the answer is yes. With a little bit of further understanding of electromagnetism, not only do we know the shapes that these magnetic fields have, but also the direction in which they're going. I hope you enjoyed this demo. Thanks for watching.